Hi, this is Kate, and we're solving linear systems by graphing. We want to find the solution to this system. A system just means more than one equation. X plus y equals 7, and y equals 3x minus 1. While this blue equation on the left, x plus y equals 7, it has tons of solutions. When x is 1 and y is 6, that's a solution. When x is 7 and y is 0, that's a solution. When x is negative 1 and y is 8. You get the idea. There's lots of them. You could probably think of 2 or 3 more, no problem. The equation on the right, y equals 3x minus 1, it also has tons of solutions. If x is 0 and y is negative 1, that makes this equation true. If x is 1 and y is 2, that's a solution. Or if x is negative 2 and y is negative 7, and again, I'm sure you could think of lots more. However, if we want a solution to the system, we need to find the x and y that makes both of these true at the same time. Wouldn't it be nice if we could keep track of all those blue x's and y's and red x's and y's, so that when we hit on the one that made them both true, we would know it? Well, luckily, we have such a way to do that by graphing them. Check it out. In the blue, if x is 1 and y is 6, I can plot that 1, 6. If x is 7 and y is 0, I can plot that at 7, 0. If x is negative 1 and y is 8. In fact, any point x, y that lies along this line is going to make that equation true. Let's do the same thing with the red equation. 0, negative 1, that makes it true. If x is 1 and y is 2, so we'll plot 1, 2. If x is negative 2, then y is negative 7. Any point that lies along this line is going to make that equation true. And notice we didn't have to plug in a bunch of points and plot them. We could have used our technique of plotting the y-intercept and then plotting some points along the correct slope to graph the line. Can you now easily see what is the solution to this system? Make the best choice. The solution to the system is where the lines intersect. That's the point that makes both of the equations true at the same time, when x is 2 and y is 5. 2 plus 5 equals 7. Also, 5 equals 3 times 2 minus 1. Let's take what we've learned and solve a new problem. Find the solution to the system. 2x plus y equals 8, and 3y equals x minus 18. We're going to graph both of these lines and see where they intersect. Which line is a correct representation of the blue equation? 2x plus y equals 8. It would help to look at the slope and the y-intercept once you put it into y equals mx plus b form. Make your choice when you're ready. Line B is our line because if we're going to put this in y equals mx plus b form, we need to subtract the 2x from both sides. Therefore, the slope is negative 2 and the y-intercept is 8. That's line B. Which line is a correct representation of 3y equals x minus 18? Once you put it into y equals mx plus b, take a look at the y-intercepts and the slopes and choose the correct line. Choice A is our line, because to put this into y equals mx plus b, we need to divide both sides by 3. 1 divided by 3 is 1/3. That tells us our slope is going to be 1/3. And our y-intercept is negative 18 divided by 3, so negative 6. Now we can simply observe where the graphs intersect and select the solution to the system. The solution to the system is 6, negative 4. When x is 6 and y is negative 4, it makes both of the equations true. So let's think about if we have a system of two lines, are they always going to have just one Solution, are they always going to have just one intersection? If we draw two lines on a plane just means a flat surface. How many points can they intersect? Points, what do you think? If two lines are drawn in a plane, they could intersect at one point, they could not intersect at all, or they could intersect at infinite points. Let's see what these would look like. We've already seen a few examples of linear systems that intersect at one point. In order for this to occur, the two lines must have different slopes and different y-intercepts. Two lines could not intersect at all. They could intersect at 0 points. This would happen if they were parallel. Recall that parallel lines have the same slopes, but different y-intercepts. Finally, two lines could intersect at infinite points if they were the exact same line. This would mean they'd have to have the same slope and the same y-intercept. So how many solutions do you think there are to this system? Y equals 4x plus 1 and 2y minus 8x equals 5. You may have to do a little work first to put that second equation, the red one, into y equals mx plus b form. Make your choice when you're ready. This system has 0 solutions. If we get the second equation into y equals mx plus b, by adding 8x to both sides and then dividing both sides by 2, they have the same slope but different y-intercepts. Therefore, they're parallel lines. This system has 0 solutions because parallel lines do not intersect. This is Kate, and we've been solving linear systems by graphing.